Not that cool. Welcome back, Calsters. There we go. Okay, today we are going to finish up our discussion of the chain rule, and you will get a lot of time to work on stuff because realistically it just takes a ton of practice to get good at these things. So, when we use a chain rule, the most important thing that we have to remember is just a general rule, right? Derivative of the outside, don't touch the inside, and then you differentiate the inside. Now, do we want to do one more just chain rule? We just did 3 essentially on the bell ringer today. Do you want to do one more big one together, or do you just want to jump in and start making them a little bit more complex? One more? Okay. So let's see here. We want one that's not like incredibly awful, but I don't want it to be like crazy easy either. Okay. So last example of just regular old-fashioned chain rule. I want us to take the derivative with respect to x of the following. And we're not going to clean it up. We're just going to, differentiate it. I don't know what I'm saying. Sorry. I want sine x over x squared. All right. Now, we are building... so used to it already. We are going to just build up the complexity. This is just a single chain rule right here. It's just going to be a little bit uglier. Can anybody see the ugliness coming? Where does the ugliness come from? Sine x over x, because we need, that's our inside, right? We're going to have to differentiate that. And the good news is we get to use the what when we do the derivative of the inside? The quotient. Cool. So let's dig through and just see what shakes out. What number is Riley normally? 9? All right, so if I get number 9, then it won't be her, right? Cool. Okay, I'll be number 9 today. Now the question is, do I try to be Riley or do I just let Holloway be Riley? I don't even know how to try to pretend to be Riley. Nope, not a clue. So 12 of us, let's see here. We're going to calculator all the way through this. Riley, that's pure coincidence. She's number 9, right? Riley, what would you do first? I would put a 2 up front. Okay. Was that an okay? All right. Like, I don't know. I'm not a good impression guy. 2 out front. Deal. Sounds good, Riley. Now what? Don't touch it. Just keep it. Sine x over x. Now it's to the first power, but I'm not going to write that. And this time, just because it's going to be a little bit uglier, I'm going to, instead of just differentiating, I'm going to take the time to say, now we take the derivative of what? The inside, I agree, which is sine x over x. And I'm doing this because I'm going to do a little bit of scratch work here. And I'm going to let this ride. I will rewrite this in a moment, but I'm going to do my derivative and I'll write it all in the same line. So let's take the derivative of this. Anybody have a song that might help or a phrase that might help? How do we take this derivative? Low d high. All right. Low is what? X. So let's do this. X d high. Cosine. Low d high minus high is sine x. D low is 1, so I'm not even going to write it. All over low squared. Okay, so that actually wasn't that bad, right? We saw that there was a, hopefully you saw there was a quotient coming, but if it stressed you out, now it doesn't need to. I'm going to rewrite this first part because I was expecting maybe more work. So here we are, 2 times sine x over x times this. And is there an obvious way or anything obvious that you would change about this? And like, for all intent and purpose, this is the derivative already. But just to check, because we might get a bunch of different forms, is there an obvious way that anybody would rewrite this? So this only turns into 1 if we take the limit of it as x goes to 0. But I like that thought because that is one of our limit theorems. Now, am I really going to distribute everything? No. But do you agree that this is the same thing? 2 sine x times x cos x minus sine x? All divided by, not squared anymore because we have x times x, but I heard or saw a couple people silently and confidently mouthing cubed. I also heard a couple whispers, but I have no idea where it came from, so kudos to you guys. Cool. This is what I would consider the simplified version of the derivative. Okay. Give me some feedback. Yes, no, thumbs up, thumbs down. Just with general chain rule, which is I would say what we're doing. How does it feel? Thumbs up is feels great. Thumbs down is feels awful. Okay. Well, let's step it up a little bit then. For whatever reason, the last... Holy cow, I tried to say next and last, and it came out as NAST. The NAST section that we're going to look at today of this 3.1, which is a monster of a section. For whatever reason, it makes me think of Metal Band. Don't know why. Anybody in here a metalhead? All right. Me neither, for the record. But for whatever reason, our last little piece that we're going to look at is what I refer to as nested chains. And not sure why, but I cannot read these two words with each other without it sounding like an 80s or 90s metal band. Now, when we say nested chains, all that this really truly means is repeated application. So repeated chain rules. Okay, in regular chain rule, and we'll just entirely up to you if you want to include this. I'll do pink so you can make that determination. If we use a regular chain rule, what we have seen up to this point is f of g of x, right? That's what we would use for a regular chain rule. There's a clear inside and outside piece. Now, if we nest this, and these are the types of problems, and it's pretty much just examples today, but we get so much cooler than f of g of x because we can start considering things like f of g of h of ... of x instead. Okay, all that we are doing when we do repeated chain rules or nested chains, we are just seeing more than two functions composing through. Now, when I think about this, it's strange, and we'll see if the language makes sense to you, so this is how I think about them. I always think it's literally like we're pushing a ddx through the problem. Push ddx through problem. And we're going to stop there. And if we have a better way to word this after we do an example or two, I'm fine with it. But we're essentially just pushing it through. Now, that probably doesn't mean anything yet, but if I try to forget to ask whether or not this seems a reasonable statement, remind me at the end of this problem to really dig in and see if it makes sense. So I only have one ready to go right at this point in time, but we can do certainly more than this. So here we go, nested chains. Okay, we are just going to push ddx through our problem. And for our first one, let's say I want the derivative, so ddx of the cosine of sine squared x. Now, the good news is that we don't even have to be able to recognize here and now that this is a nested chain. If you do recognize it, awesome, but if you don't, you're still fine with it. When I talk about pushing ddx through, does everybody agree that the derivative ddx is on like the leftmost side? So I'm going to start differentiating it as normal, and each time what we're going to see is this ddx, it moves further to the right until we don't have anything else to differentiate again. That's my pushing through statement. So without any further ado, let's just jump in. I'm going to use like a really obnoxious color to show the ddx each step along the way, and really I'll probably just keep it blue. But let's go through here. Right now, what is outside? So the cosine, cos, and we take the derivative of the outside first, right? So what's the derivative of cosine? It's not sine. Negative or minus, I would use negative. Negative sine of, what do I do with the argument? Yeah, keep it. You can look at it, you can write it, but don't touch it. Sine squared x, and then here we're going to see that push through. I then need to take the derivative, d dx, of what? Sine squared x. Now, we did a problem similar to this on the bell ringer, right? Sine squared is really sine of x, that quantity, all of that squared. Which means to take this derivative, what do we need? So I'm going to rewrite this. It is entirely up to you if you want to write it again, because I'm only going to change one little tiny thing. But this green part is already good. I'm not even going to bother with it. And then instead, if it makes it a little bit more obvious, just based on the silent response that I got, if I write it like this, and I would never encourage you to do this except for this like very start of learning it. If I want to take this derivative, what do I need to do? So you're right, the 2 is going to come out, but is this another chain rule? This is just another application of the chain rule. Because I have a clear inside and outside, I'm going to make that note. This is another chain. Or realistically, I want to say another link in the chain, but that doesn't really make sense here. Another chain rule. Okay, so notice my d dx went from the front. Now it's in the middle of my problem. So we're going to just see what shakes out. Do I have to touch anything in green ever again? No, I'm already done with all the green stuff. It's already been taken care of. We are just working our way through, shoving that derivative from left to right. So it's the negative sine of sine squared x times, and then let's take this chain rule. I don't remember who it was. Somebody said the 2 moves out front. Do you guys agree with that? 2, and then what do I do with the argument of a chain rule? Keep it, sine of x. And now, again, you do not have to do this every single time, but it's good practice. I will multiply then by the derivative, d dx, of what? Sine x. And I'm only doing this d dx every step along the way so that you can physically see it's pushing through the problem, right? It started leftmost side, and then it pushed into here, and we pushed one more time. This is our last step, because I'm not going to need another chain rule here. We could write another chain rule if we wanted, but it's not necessary. Have I lost anybody? So one more step. Let's see if we can get this to work out. This is the negative sine of sine squared x times 2 sine x, and I'm removing parentheses as appropriate, times, what's the derivative of sine again? Cosine x. Now, if we really wanted to, and I don't think we need to, but if I look at this, this really is and truly is a chain rule, but I don't have to write it because what's the inside of this? The derivative is 1, right? So we don't really write that last chain. At this point, are we done? I have started and pushed d dx, or my derivative, through the entire problem. The only thing that is worthwhile to do at this point is just agree that there is a way we could rewrite it. There's not a single correct way that it could be rewritten, but is there a nicer way that we can all agree this could be written? I wouldn't change a lot. People are going to try to possibly multiply these, but can you? Why not? The arguments don't match, so they're not like terms. The only thing I would do is I would just move the negative 2 sine x cos x out to the front. Negative 2 sine x, that's this one, cos x, this one, times the sine now of what's this last argument? Sine squared x. And they're ugly. The cleaning up part, we're never going to agree on what's... Okay, that's probably not true. We will not always agree on what is the nicest version of a function, but we are completely done with our nested chain. Feels all right, feels awful. Okay, should we try another one together? Do you want to try one at your own desks? Okay, so I want you guys to try one. I'm really tempted to just make up a problem, but every time I do that, it winds up awful. So we're going to make it not that yet. Oh, that's a neat problem. Okay, I want you guys to differentiate for me. Find me d dx of the following. And I'll pause this as soon as we get it written. Ooh, there's so many good problems in here. I like all of them. Sorry, I had a really awesome one and then I lost it. Here we go. I want you to find me the derivative of x squared times the cosine of, ooh, okay, I'm going to mix and match. If this comes up terrible, I'm so sorry. 3 to the x squared. We are nesting our chains here. I'm going to give you guys a minute. Riley, if you're watching this, go ahead, pause the video, and you will see a walkthrough in 3, 2, 1. Looking at this, right off the bat, there's a couple different things that I notice, and I'm hopeful that you do. If we forget about all the chain rule stuff for just a brief moment, if I want to find this derivative, what's happening between these two pieces? They're multiplying, which means we have to or get to use the what? So it's a product rule going on here. Now it happens to be a product rule with a chain rule included, but let's deal with the product first. So here we go. For the product rule, I don't remember the product rule, unfortunately. First times the derivative of the second. Okay, so I can handle that. Here's the first. Okay, times the derivative of the second. So now, and again, do you want to see the ddx's every time we do this? Okay. First times the derivative of the second. So we'll go ahead and write this out. The second is cosine of 3 to the x squared plus the second, so the cosine of 3 to the x squared times the derivative of the first. And on this one, I'm just going to write a 2x here since there's nothing crazy that has to happen. Everybody okay with that first step? That's a wrong way to ask this question. Is there any questions about this first step? Now, if you didn't recognize a product rule, you have no hope realistically of getting this problem. But it's easy because if you missed it this time, you probably won't again so long as you don't just magically erase. So now we're going to take the derivative of this piece. And all of our work might look a little bit different. My rule of thumb is that if you think you've shown enough work that I could follow along, I'm probably okay with it, realistically. But the more work you show, the easier it is for me to give you partial credit, things like that. So let's knock this out. This becomes x squared times, what's the derivative of cos of 3 to the x squared? What's the outside and inside of this first? Outside is cosine, right? And what's the derivative of cosine? Now, I'm going to do something this time, which if you're working still, be very, pause for a second because I want you to see this. When I do negative sign, I could write negative sign like this, yeah? Or do you guys agree that I could just do negative sign? Does that still cover it? I'm just moving it out and I'm making it look nicer as I'm doing it through the problem. Now, if you don't like that, that's okay. We can just leave it here. Negative sign of, what happens to this argument? Nothing. It stays the same. 3 to the x squared. Now I'm going to take this times the derivative, d dx, of what was my inside piece of my derivative here? 3 to the x squared. And then the rest of this, again, just like before, we're already kind of done with this piece. I'm going to rearrange it so it looks a little bit nicer. This is 2x times the cosine of 3 to the x squared. Okay. Uglier problem, but notice inside here, which is apparently purple, I thought it was the same color. But we're just pushing a chain rule through that first piece, right? Nothing different. I'm missing a parenthesis, so I'm going to add that. Otherwise, it's going to bug me some more. Is that really the color I used? No? Is that the same color? I can't tell. I don't think it's that one, is it? I don't know. Close enough. Okay, looking at this. Now we just have to take the derivative of this piece. So everything else ultimately stays the same. I am going to clean up this first little start here. Any objections now to calling this negative x squared sine of this? This piece, I'm just going to move the negative out front so it's a little bit nicer. That's awful, and I don't know why. Weird. Oh, there's a mark on my computer. Okay. So negative x squared sine of 3 to the x squared. And now we need the derivative of this piece. Well, that's an a to the u situation, right? So I'm just going to use the rule. We should be able to see it in our notes, or you'll turn back one page. It's a to the u, which in this case would just be 3 to the x squared, times the natural log of what is our base? Natural log of 3. And then it'd be times the derivative of x squared at this point, right? U prime, which is what? 2x. And we still get our lovely plus 2x cosine of 3x squared. Sorry, 3 to the x squared. And the problem gets longer, for sure. It definitely does make the problems longer. But if you go step by step all the same, it shouldn't matter if it's a single problem that takes 10 minutes or if it's 2 or 3 problems that take 10 minutes if we're just doing the chain rule. Either way. Now, this one is exceptionally ugly in my mind. I forgot a plus sign right there, so I'm going to get that. And let's see, did I get... Nope, there's not a plus sign right there. That's a derivative of x squared, right? Here's my plus sign that should be there. Is there any obvious rewriting that could happen? So all of these, what's happening between all of these terms right here? They're all multiplying, right? Like, and I've already done all the derivative. There's nothing left to do derivative-wise. I would see this 2x. I want to move it out front. I would call this negative 2x cubed. And then this is really just a stylistic choice. Do you want the natural log of 3 to show up? Does it really matter where it shows up? Not really. I'll go ahead and just keep it where it is. Sine of 3 to the x squared times 3 to the x squared times the natural log of 3 plus 2x cosine of 3 to the x squared. Okay. Here's the honest truth about it. I have no idea what this expression means, or I don't even want to think about solving it to begin with, right? Like, that's awful. We don't have to do anything with it if all we're finding is a derivative right now. This could give me a bunch of information about my graph because it's a derivative, but for now, we're just finding derivatives. This problem, noticeably harder? Maybe. If you say yes, I think that's a reasonable thought. We still have to remember all of our other rules, right? We have to remember the product rule, the quotient rule. It just happens to be that maybe we get some extra chains to deal with. Okay, there is no way to get good at something without being kind of bad at something first, which means you guys need practice with it. I'm a-okay with giving us a bunch of time for practice starting right now in the form of our assignment, but I want you to have the next 15-ish minutes to work in class so that when there's questions and we need to do something together, we can. So, with that said, I just don't know how I did that, but we'll go over to Calc and we'll look. And let's see, no homework over the weekend, unfortunately, but today we do get it. So this is lesson 3.1.4. We just did nested chains. And your homework tonight is waiting for you on, do we do any 3.1 homework yet? I guess I can just look there. 3.1.2, page, that can't be the right page. It must be 227. And I want you guys to do 33 through 53 odd. And then I don't know that I really have to do this, and I don't, ooh. Yep, I'm okay with these. Cool. 33 through 53 odd. This is due tomorrow. If you are struggling with it, when am I available? Before school, after school, at lunch. Right now, right? Because we get 15 minutes to work on this. I want you guys to go ahead and get started working on this, and I'll get some tunes going. I'm not going to quite end the video in case there's questions on the homework that I should record, but I'll give you guys a head start on it now, and we will either end or resume if there's questions.